move to our third presentation in this block, and presentation is coming from Professor Zoran Stevanović. And Professor Stevanović is chair of Department of Hydrogeology at Belgrade University, where he teaches a variety of courses in hydrogeology and groundwater engineering. He was project manager and consultant on numerous national and international research and applied engineering projects. Dr. Stevanović serves as expert for the United Nations Food and Agriculture Organization. He is member of Karst Commission of IIH, and he is editor of several books and numerous papers on groundwater. He is current president of Serbian Geological Society, and I have pleasure to know Professor Stevanović for more than 30 years. Let's say there. Please, the floor is yours.
Thank you, Chairman. Thank you, Neno. So, dear colleagues, ladies and gentlemen, distinguished guests, co-author of our paper is Dr. Francesco Fiorillo from University of Sannio in Benevento, Italy. So we prepared this an overview of the situation in the groundwater use and specifically karstic aquifer use in the Mediterranean basin, where the karst represent the major source for the water supply. So when we consider the karst as one of the topics of this conference, it is from this slide you can see that even the distribution of karst is not equal to its importance in utilization. So we have about between 10 to 15% of carbonate or evaporitic rocks spread around ice-free land, but more than 20% or about even 25% population of the world consuming the water which is related to these aquifer systems. When we come to the situation in Mediterranean basin, even with much more distribution of the carbonate rocks is all around this area, and from this slide even is shown that blue color is much more dominated than green. What is the difference? The blue color is presenting area with the carbonate aquifers, while the green is evaporitic rocks, the much better quality we and the fresh water reserves we can expect in these blue color areas. Why the karst is so important in this region? In an area along the coast, we have the so-called littoral karst, while in adjacent area, it's dominating high hilly or mountainous or high alpine karst as well. So problems in utilization of the karstic aquifer along the coast is related also to salinity problem, or water salinity problem, due to the intensive extraction of water in some of the large islands and cities along the coast. We have intrusion or saltwater intrusion, as we have seen from some of the slides of Dr. Ken Howard. So in some other area, a little bit inland, more inland, let's say in a hilly mountainous area, we have much better situation, and fresh water is dominating. What we always consider why we have this problem of the salinity and position of the aquifer system, it is also related to the recent geological climate changes in the past. So for instance, we have a completely different situation. Messinian salinity crisis, for instance, resulted with a high evaporation rate, and today Mediterranean basin and water level in that basin was for more than 2,000 meters lower than it is today. Then we have another period of more recent in the glacial period, in glaciation, when during the Quaternary the water in a basin was some 60 to 70 meters lower than it is today. So many of the springs today are submerged, previously were simply on the coastal area or inland. So this is one of these slides where the Gibraltar moraines was completely closed, and this Mediterranean Sea function as today we have this Caspian Sea, for instance, which is sea locked, let's say, and there are no access to the other saline water. So many of these changes took place in the Messinian, during Messinian age, geological, which is, was some 6 million years ago, but this impact has still some of the consequences on today groundwater distribution in the Karstic aquifer. So this here is also one of the slides showing the sea level, which was about 100 meters of that which is today exists. We have in this Mediterranean region and the adjacent areas, this is the area of so-called classical karst. Thanks to works of Zoran Stevanović, as a founder of karstology and karst hydrogeology, he did his extensive survey just in the area of Kraso, in today border area between Slovenia and Italy. And thanks to his work, the new scientific discipline had been established. So all these mountains area we can see on these slides are in fact the part of the alpine geostructure. This is alpine branches. And Stevanović's work was so important that in that time, let's say end of the 19th century, he did a lot of his visits of the major karstic phenomena and described them in his book, The Karst Phenomenon, which in fact became one of the foundation for the karst hydrogeology today. What is specific in the Mediterranean basin? We have some regions like, for instance, Montenegro, where it is the highest rainfall rate in entire Europe. In a certain part, the annual precipitation rate is reaching even 8 meters annual rate. It means 8,000 millimeters. And due to this enormous amount of water, you have some of the world's largest streams allocated along the coast. In addition to the karstification was very intense in that area. It's repeated in several orogenic phases, geological. The recent glaciation also supported very much karstification intensity. And today in this classical karst we have developed all classical geostructures, for instance, and the features. Some of them are small sizes, this is like carens or dolines, ponors, but we also have the very large caves and caverns. And most important maybe are the karstic polje, which are the largest in this part of the world. For instance, Livanjsko polje, with its surface of 380 square kilometers, is the largest in the world. So here is also slides showing, these two slides showing the Popovo polje, which is today regulated, today is regulated the largest sinking stream in entire Europe, Trebišica River, and where the two large reservoirs have been built and completely today controlling the water flow, and in a proper way is utilized this polje, which previously was flooded for more than 200 days every year. This is the list, for instance, of the large potholes and caves in Croatia. Some of the big caves are among the largest in the Mediterranean basin, with a length of explored channels of more than 20 kilometers. Groundwater flow direction and many tracing tests in fact supported and defined the connections between large swallow holes, ponors, and the drainage part. And velocity obtained from this test sometimes showing the enormous fast movement of the groundwater. In fact, you have almost waterfall in the ground. For instance, velocity of half meter per second was registered in some of these tests. So groundwater flow directions and movement are vary very much depending on the ground of the high or low water periods in that part. And sometimes we have connections between the different springs and corners depending on the water table position. The taping of the karsting spring in Mediterranean basin, in fact, was a very ancient art. For instance, in Rome, about 13 cubic meters per second was supplied from the various karstic springs, some of them even 90 kilometers far away from Rome. And some of these structures are still functioning, so providing water below the center of Rome and to the major springs and fontaines. So this enormous amount of water utilized in that time, in fact, was one of the first signs of the new, let's say, sanitation and the water sanitation techniques, and very much improved the sanitation situation in the city. Many of the structures, like the large aqueducts, been built in that time. Here is also one of the big palace of Diocletian, of the Roman emperor, was established near the city of Split, Spalato, where the large karstic spring Jadro being tapped and still used for the supplying the city of Split. So such a spring, in fact, or many others, are located on the little bit higher elevation due to the good geology, let's say, because impervious barrier, it's above the sea level. In case of Split, this is 50 meters above today's sea level, while, for instance, for the city of Dubrovnik or Ragusa, we'll see it on some other slides, it is just a 2.5 meter, but still sufficient that we have fresh water and we have no any changes in the water quality throughout the year. So here is also a number of the location of the investigated submarine springs along the Mediterranean basin. As I mentioned, due to the variation in a sea level, many of those springs were previously just discharging at the surface, but today they are submerged, and it is not an easy task to utilize such a water in the basin. Here are also some of the location of the freshwater intakes and tapping facilities, in fact, where the separation of fresh and the saline water has been done. Some of these springs, for instance, are well described in one of the books which Neven Prešić and myself wrote a couple of years ago. For instance, this is location of all springs we describe in this book, and you see the highest concentration was exactly in an area of former Yugoslavia, Greece, Albania. We not describe these springs because we are from that area, but simply it is really extraordinary example of amount of water which appear on some of those springs. In the entire region and adjacent areas, some of the capitals are also utilizing the karstic water. Among them are Vienna, Tirana, Skopje, Sarajevo, Podgorica, Rome with the 60%. And this is also due to the high balance, and in some area, like in Montenegro, you have average specific yield which is higher than 40 liters per second per square kilometers. So really large amount of water, which sometimes cannot be even properly utilized and controlled due to enormous flows and enormous energy which these springs are providing. So in this slide, so down left, you can see that spring of Sopot in Montenegro, when discharging flow can reach the rate of near 200 cubic meters per second in the high water period. But in the low period, it is just water is flowing below the sea level as a submarine spring. It means the highest variation and problems in utilizing of such springs. Here is the spring of river of Ombla, which is supplying the city of Dubrovnik, and this is one of very typical example where, for instance, we have this transboundary aquifer system. For instance, the border between the Bosnia and Herzegovina, where 95% of the catchment is just along the ridge of this hill. It means that just 5% and discharge point is in one country, while our catchment is in another. Some of the springs are so well known and so properly explored. For instance, we call this Fontaine Vaucluse as the king of the spring. It's just because on one side it is well explored, the deep channel of these springs being explored by the divers, and on the other side, this is the longest period of the observation. So we have, for instance, on that spring, more than 100, almost 150 years of continual observation. So we all had George's dream to have a similar situation with our springs in the region, but unfortunately, very few of them are so properly observed and data was collected. So also it is clear from this figure that we have some climate change impact. There are some reduction, which is not so large, but however, showing that an average flow at the spring are declining slowly. So this is sometime evidence that we could make and face a problem in the future with some of the spring. So now quickly I will pass through the country along the coast, but before that, this is one of the typical example of the problem we could face in case of the unconfined open aquifer system in Karst, which are in connection with the seawater. So in this case, sometimes the stream is, and this saltwater interface is moving inland. Sometimes some of the specific structure are needed to separate this water, like an attempt with the dam on the right figures, and some of such dams are functioning well in the Mediterranean basin, but in many places they are not successfully control the water. Here is one of the spring who is facing such a problem. For instance, this is you can see on that slide from the French coast, some of the spring which is directly connected with a direct connection between the fresh and the seawater was established. In some cases, like for city of Montpellier, this Port-New spring is controlled by one dam which is built in the deep ground in order to establish disconnect the fresh water and the salty water. But in fact, before damming, we had situation with 18 grams per liters in sometime in the maximum salinity of water, while today it's better situation, but it cannot be completely separate these two. In some other places, like for instance close to Mortola, which is a city nearby Italian and the French border, some attempt to tap the water in the bottom of the sea, in fact by some specific structure, like you can see on that slide, 36 meters below sea level, was not completely successfully separate the water. So however, we still have this brackish water instead of completely fresh. In fact, one of the excellent example, it's a little bit further from the coast. Of course, it's a utilization of water for the city of Vienna. We just showing here because it is one of the really engineering masterpieces from the end of the 19th century, and the city of Vienna is obtained the water from the distance of more than 100 kilometers from the city. Water is of excellent quality, and under catchment is in unpopulated areas, so it means that it's really something that engineers learn a lot from such a good example. Another structure also important in the Mediterranean basin is the Peschiera spring, which is supplying the city of Rome with 60% of the fresh water, where also the large gallery has been constructed inside the karstified rocks. This structure was completed some years before the Second World War, but still is working very well. One of the largest springs in the Mediterranean basin in Italy is the Timavo spring, just with an altitude of, let's say, 0.5 to 1 meter. It is just Slovenian river Reka from Škocjanske Jame. The cave system is drained in the Timavo. There are also some other springs in the southern Italy. For instance, this Pugliese aqueduct is one of the largest, supplying water partially to city of Bari, another part to the city of Naples. Napoli, and also this is the catchment area of the Cervi Alto Massif. In tomorrow's presentation of Dr. Fiorillo will be some examples more shown, and for instance this Caposelle spring, this is a picture from the beginning of the 20th century, where before intake being constructed, this is how we see this area today. Then we just will pass through Slovenian Croatian coastline. Rizhana is a spring which is supplying all Slovenian coastline, which is in fact is not that large, it's about 40 kilometers long, but the amount of water is successful to cover all demands. Then we have a group of the springs supplying city of Rijeka, and then already mentioned springs of Jadro and Ombla, which are the largest in the area. Karst in Bosnia and Herzegovina is also highly developed and well explored. For instance, here is the spring of Buna, which is one of the largest karstic springs, not only in the Mediterranean basin, but in the whole world, because in a maximum this spring is discharging more than 350 cubic meters per second. It's an enormous large area. Catchment is over 1,000 square kilometers. In Montenegrin coast, out of this so-called spring, there are many others along the Kotor Bay, for instance, but they were not being utilized just of this because of this variation and the problem with the saline water intrusion. So we will see at the end of the presentation how we have solved the problem of the supplying water to the coastal area of Montenegro. Here is the Albanian spring. There are plenty of springs which discharging in average more than 200 liters per second. All these red dots are in fact the springs, and green is the areas of karstic rocks. So here is the so-called Albanian Alps, while in the south we have also some of the very large springs. Tirana water supply is also utilizing the karstic springs, Selita, Šemrija, Bubila. Today, some of them are submerged by the artificial reservoir or lake, but let's say king of the Albanian springs is definitely the so-called Blue Eye spring, where discussion to utilize this water for the southern Italy took place, and you see here proposal how to divert this water on the 70-kilometer distance below sea level to supply Puglia, which is one of the largest consumers of the water for agriculture, for irrigation purposes. So, but this is still under evaluation and discussion. Average discharge of these springs is 18 cubic meters per second, and the catchment area is very large. Karst in Greece, you have also, you can see a lot of karstic carbonate rocks. Some of them, the largest area are in Peloponnesus Peninsula, and also on the Creta Island. So Thessaloniki, for instance, is one of the largest cities utilizing the karstic water, but is combining with the alluvial aquifer as well. So here is also one of the successful intake, which is built along the coast. You can see this coffer dam here, which is in fact preventing mixture of the salty water and enable utilization of the fresh water in the Peloponnesus. Here is another spring, Almiros, which is supplying water to the Iraklion, the major city on the Creta Island, but there are problems with the salinity during the low water period when discharging the springs is falling below the 3 cubic meters per second. Here are the karst of Turkey. A lot of these springs are located close to Mediterranean Sea. These springs supplying the major touristic centers, and some of those springs are really of the large discharge. The largest one is Dumanli spring. Today is impounded by Ojma Pinar reservoir. Its average discharge is 50 cubic meters per second, not maximum, it is average. So if we move a little bit more south along the Lebanese coast or closer to Syria, we will also have a lot of karstic areas and a lot of karstic springs. Of course, they are characterized mostly by the problem of the variation of the discharge, sometimes a mixture with the saline water, and in some cases, like in Libya, tapping this so-called Lagoon Blue or Ain Zaina spring for Benghazi in Cyrenaica Peninsula resulted with an intensive pumping, resulting even with an increase and movement of this fresh and saline water interface more inland. So it means that there are problems with utilization of such a kind of the spring. In the project we are currently running, this is the World Karst Mapping or WOCA project, where IIH is supporting it, and leading association, leading institute is Karlsruhe Institute. We are mapping, in fact, all springs and preparing the database for the major springs and well fields in Karst. And from this map of part of Mediterranean basin, you can see the density of the springs and the data collected about them is major in a part of the former Yugoslavia and the Turkey and some other areas around. So the statistic of this project is saying that out of 124 large springs, 1/5 of them have minimal discharge, which is larger, greater than 2 cubic meters per second. The major number is in Bosnia and Herzegovina, 8, and Turkey as well, 8, and then Montenegro is the second with the 5. Who is the leader in the utilization of the karst water? This is the country Montenegro. It is more than 75% of all water is utilizing from karst. The second in this order is Albania and Austria, where the more than 50% are utilizing. Some other percentages is a little bit smaller, but still considerable. How to control the flow? So there are a couple of options to tapping the spring flow, to utilize more water and drill and pump the water in the spring proximity. Also, we all learned from excellent example and an engineering and ecologically best solution which is applied for the city of Montpellier. In France, the famous source Les is supplying the city. You can see how demand is increased and also extraction of the water. This intake is very specific. It was first exploration of the caves being done by the divers, then installation of the pumps took place in the channels, and the final solution including the deep shaft which is pumping water and result with the drawdown much below the normal source water point, but one pipe is diverting water directly to the source point and providing this 400 liters per second, which was minimal discharge of the spring of Les. So it means all ecological requirements and the water-dependent ecosystem was covered by this amount of water. Controlling an attempt to control the aquifer system, not only for stabilize its discharge, but also to generate energy, is prepared for the city of Dubrovnik. For instance, this proposal how to build the 3-level ground curtain along around the spring and increase head for about 50 meters in order to utilize energy. This proposal is still under evaluation and discussion, and if satisfied the demand, ecological demand, it will come to effect. So this is the idea of Peter Milanović and his team, how to expand, enlarge, and let's say increase the level of the water table. Here is how we solve the problem of the supplying water to the Montenegrin coast. Idea to tap the water along the Skadar Basin was very old. Discussion took place for more than 30 years. The enterprise responsible for this water delivery was established 30 years ago, but nothing has been done because the primary idea to tap the water from the one sublacustrian spring, which is 23 meters below lake level, was unfeasible, and 6 or 7 years ago, according to idea of Professor Radulović from Montenegro, we all convert to another spring, Bolje Sestre, which is just 1 to 2 meters below lake level. We have recently just visited that spring, and this pipeline is 40 kilometers long to reach the coast, and then from there there is another 100 kilometers of the pipeline constructed to supply 1.5 cubic meters per second to the coastal area. All of us who spent some of our holidays in Montenegro, we remember very well the days when in the hotel was written, "We have waters." That was the advertising where you have to spend your holiday. Today, just recently we heard from the director of the regional water works that they increased the income from tourism from 200 millions some 10 years ago to 800 millions in this day, mostly due to the stabilization of the water, drinking water delivery. Why I took this example, I was lucky to be involved in this project as one of the engineers. And here are some slides showing, for instance, special thermal visual camera, which recorded, in fact, this subsurface flow along the coast. And this is how this spring looks in the beginning of the project. We had many problems to separate this fresh water, even to properly measure the flow of the stream flow. We also employed the geophysical method, the hydrogeological mapping, tectonic analysis, diving, then permanent sampling and analysis. Drilling also, we established somehow good monitoring system, and this is the final engineering solution. Is really something that we have to be proud on that, because we have here mobile rubber gate, which is in fact by support of the two compressor room, put in a situation when the lake level is rising to separate the water in the lake from the fresh water. So it means this mobile gate is an important part, and coffer dam is important part of the project. And you can also see from after a couple of slides how location of the springs looks in the beginning, and here is the final phase of the construction, and here is this mobile gate which can be activated in case of the rising water level in the Skadar Lake. There are just for this spring is an excellent example of the excellent water quality. So just UV disinfection is taking place here, and some chlorination in the pipes along the coast. So no other treatment is required, although the filters been installed in this intake. So it means we have really excellent water quality. But what is not in favor of this project, it is how the reaction of the local municipality along the coast looks and how they look on this project. They simply don't use more than, believe it or not, 20 to 25% of this water, because every single drop of this water is measured and should be paid, not in a large amount. The cost is the same like local sources, but simply local municipalities and waterworks try to avoid to use the water except in the touristic season. So there are managerial problems because the credit is very large and it has to be returned to the bank. It is 100 million euro is the total cost of the project, and regional waterworks are in fact in debt due to the non-properly utilization of the state. So lessons which has to be learned from such a attempt to control the water is that you have to have good data on the discharge regime, you have to know position of the karstification base and intensity, and as well aquifer permeability. There is pressure on the aquifer system will definitely increase. Some of the projects we also work as a CC Waters project, and experience obtained from this project showing that in some cases some karstic springs will additionally deplete their reserves during the period of the low water. For instance, in some springs we accounted that during the summer season this may result with a reduction of even 40%. So it means that there are many attempts to be needed to ensure the stable water supply. Everything we have discussed about the Mediterranean basin itself is more or less we're discussing how to make this in a sustainable manner, how to ensure the water demands, ecosystems and so. But if you switch a little bit further from the area along the coast and touristic area, you will meet many areas where simply you have to cover communitarian demands. So some of the country is really affected largely. Well, depending, they have aquifer system in the intergranular porous media or in the karst, and definitely many measures should be done to ensure this so-called sustainable use, or at least to cover humanitarian demands. How to mitigate this problem? On one side we have high risk of pollution because karstic aquifers are very vulnerable due to the open cavities in the system, and on the other side we have intrusion of the salty water on many spots. Here is also the problem, creation of the new countries in this part what former Yugoslavia is, resulted with many transboundary aquifers, and many of them should be properly managed. An attempt is done recently in the Dictas project, which Neno Kukurić was led. But we hope that this and such a project will get a new chance. Also, why this area is for us important from academic point of view. This is the third year this June that we completed the course in characterization and engineering of the karst aquifer, and this project is supported by UNESCO and several other organizations in the region. Up to date, we had about 60 students, some of them are in this hall, and a number of those which we expect to come in the future years is also something that will probably spread more knowledge and information how to regulate the karstic aquifer and how properly utilize it. Thank you for your attention.